Hi everybody, I am Dr. T. Miranda Lakshmi, working as an assistant professor in the Department of Computer Science, St.Joseph College, Cuddalore. Today we are going to see the deadlock prerequisites, or you can say it as Kaufman's 4 condition. So in the last class we discussed about what is meant by a deadlock. So there are 4 deadlock prerequisites. The first one is mutual exclusion, and the second one is wait for condition, and the third one is no preemption condition, and the fourth one is circular wait. So first we can discuss about mutual exclusion. So before getting into these mutual exclusion or wait for condition and all, what is called as deadlock prerequisites? If these 4 condition occurs, then the deadlock will surely occur. Or if any one of the condition occurs, then the deadlock will occur. This was framed by Kaufman. So it is called as Kaufman's 4 condition. The first condition, mutual exclusion. So the resources should not be shareable. If the resources are shareable, already I told that in the deadlock, if the resources are shareable, then the deadlock will not occur. When the resources are not shareable only, the resources, that the deadlock will occur. Each resource should be exclusively given to a particular process. So when you're going to have a resource, if I'm going to have a printer, I have to give to a process and I have to say this is only for you, it is not for anybody else. If that is the case, then sure deadlock will occur. So the occurrence of one should prevent the occurrence of another. For example, if you're going to take devices such as printers, tape drives, plotters, so these and all are resources which is not shareable. So mutual exclusion means exclusively we have to give a resource to a particular process. If you're going to give exclusively to a process, then the deadlock will occur. This is the first condition Kaufman is framing it. The next condition is wait for condition. What is this wait for condition? Wait. We have to wait. If any process is going to wait, then sure the deadlock will occur. A process should wait for another process to leave its resource. If a process is going to have a printer and another process is going to wait for that printer, then surely the deadlock will occur. So wait for condition will happen when a process waits for another process. The next one is no preemption condition. Preempt. Already we have seen about what is meant by preemption. Preemption means when a higher priority process is going to request the CPU. Just I want this process. If it is going to request, if you are going to preempt and if you are going to give the priority for higher priority, and if the lower priority is going to come out of the CPU, then it is called as preemptive. But preemption should not occur for deadlock. A process should not preempt another process to give its resource. So when the resource is being requested by a process, it should not preempt and it should not give the resource. If preemption does not occur, deadlock will surely occur. This is the third condition. And the fourth condition is circular wait. So already we have seen the graph. The graph consists of PA and PB. PA is a process which is using the resource R1 and PB is a process which is using the resource R2. PA is using the resource R1 and requesting for R2. Similarly, PB is using the resource R2 and requesting for R1. So here circular wait. Circular wait, so if you're going to consider in this graph, if a graph results in circular wait, then the deadlock will surely occur. So if you're going to take in this graph, see here, the above figure forms a closed loop. If you're going to traverse from here, if you're going to traverse from R1, see here, we're going to traverse and we'll be finishing the node where we have started. So if there is a closed loop, then it means that deadlock has occurred. So these are the 4 important conditions which the Kaufmans have framed. Mutual exclusion, wait for condition, then no preemption condition, and the last one is circular wait. So if you're going to take mutual exclusion, exclusively a process should be given a resource, then the deadlock will occur. Wait for condition, a process should wait for another process to leave its resource, then the deadlock will occur. No preemption, if preemption does not occur, deadlock will occur. Next one is circular wait. If a graph results in a cycle, then you can say it as the deadlock has been occurred. So these are the 4 conditions. Thank you.